Good afternoon, guys. Today's discussion is about sentiment analysis and market basket analysis. So uh, today I covered the sentiment part, and for let me just mute my speaker. Okay. So today I covered the sentiment analysis part, and we make another hands-on experience overnight. Next class, I jump into market basket analysis. So there's some heads up. Your next assignment due is October 14th. So I already posted over Moodle. You get the knowledge of doing that today. Just a moment, my voice is just. Okay, from next class onward, please bring a Microsoft Excel with yourself, so we can have some. We start prescriptive analytics, which needs we work with the Microsoft Excel and probably legal. So having that software needed, most likely all of you already have it on your system. So last few weeks, we had text analytics application, concept methodologies, we had documented classification, and we had a NIME experiment using lexicon-based sentiment analysis. So can anyone summarize or just tell me what does lexicon-based sentiment analysis means? What we did generally?
So it kind of collects or takes out reviews or opinions or comments on something from website sources or social media sources.
Mm-hmm.
Out of that, it picks up the words, like it's a positive word or a negative word. Based on that word, it creates it summarizes like positive minus the negative, then divided by total number of words. That's how it creates a sentiment score. So from that we can identify regarding the topic either the positive about that is sorry the sentiment about that is positive or negative.
Okay, that's really a good summation. Also, the way that we find positive or negative words is through some dictionaries that already people spend time and identify if a text document has a positive or negative sentiment. So do you remember what was the accuracy of our prediction at the end? 74%. So today we use another type of sentiment analysis, which basically each word works as a variable. We use machine learning algorithm trying to predict sentiment. Basically, sentiment means just belief, view, opinion, and conviction about certain topics. So, for example, for the stock market, you have seen that the president's health situation is improving, and it had a positive effect on the stock price. So, what happened? Basically, you can consider each document consists of words. Each word is a variable, and use those variables to predict if it's going up or down. So let me show you an example here. I think I should stop shade here. Let's see if I can. I should allow the other people to share. So let's see if I can, how can I do that?
Hey Hamid, I don't hear you. I cannot hear you. I cannot hear you, Hamid.
Can you hear me now?
Yes.
Okay, that's great.
Can you start again?
Can you see me now? Can you hear me now?
Yes, yes. Can you start? Explain it again.
Okay, okay, that's good. So President Trump, and instead of putting healthy there, we wrote the root of healthy, which is health. Release, what is the root of release? Or a stem? If we do a stemming, we just keep the root of the words. Otherwise, we have too many similar words. So like release, releasing, release, so all of them has the root of release. So and soon. So assuming this is my observation, I call it observation 1, and let's say I have like 2,000 observation. Or what does it mean? I'm checking 2,000 sentence. So each sentence could be an observation. Let's say on top of soon, I might have stock. I might have market. Or other words. So which stock, market. Oh my God, my handwriting is not great. So let me just keep. So, and my dependent variable, or y, could be just change the stock value, the set, or just overall market value. So it could be, let's say, go up or down. Let's say it goes up. So in this observation, in the sentence that you see, I have president, so I put 1. I have Trump 1, health 1, release 1, soon 1. Do I have a stock? 0. Do I have market? 0. And for sure, I might have 1,000 different words, but none of them repeated. So for all of them is 0 too. You might put another sentence. That sentence could be 1, 0, 0, 1. Let's say 0, maybe 1, 0. For them, maybe some of them are 1, some of them are 0, and it's down row. So my dependent variable is just could, or for up, you could put 1 instead of going down, you could put 0. So you just put a numerical value instead of up and down. So as you see, now it looks like a simple prediction. So you have some variables, which are your words. So for each word, you can say I have a vector, and each word or character works as a variable. Similar to simple prediction, you can have feature selection, you can have resampling, and now you can apply several different algorithms to do your prediction. So, but no worries, all of them happen automatically through some package or modules that you use in 9. So basically use some packages or modules to convert sentences to variables. Make them like here 0 or 1, then you can use it in a simple prediction. Or it could be a picture or a voice or a video. At the end, you convert non-numerical input to some numeric equivalent. So even in future, you might have some text and you want to do prediction. So for example, you throw a picture to an algorithm and you want to predict which animal is it, or is it any threat or anything. So at the end, you need to convert non-numerical inputs such as a sentence or a picture or video or a voice to numerical equivalents, and at the end you do prediction. So any questions so far?
And how can we get the data? I mean, these review data or whatever is commented.
So there is okay, I'll explain later, but basically there is some packages or coding or some modules that you connect your Python code to a website to read that, scrape the text, and bring it into your model. So there's another component that you need to use to read like CNN.com or ABC News or Fox News, those kind of things. So use some modules to read from those websites. Again, you use some modules to convert them to numerical equivalent and some modules to do prediction. So let me just, okay, just keep your question, explain further, but any other questions? from people over Zoom? Okay, so if I hope you understand what I mean from conversion from a textual document to a numerical equivalent. So let's look at an example here. So in this case, your friend asked how to get those documents. So some of them sometimes given, which are through the example that I'm explaining now, but you can do extra work and see how you can read from those texts. So let's say it could be a tweet coming from CNN, Fox News, you name it, even Google News. All of them, there is some textual documents. For Twitter, there is two options. One option is free, which you get a very small percentage of the data, and you need to scrape the data, but you can pay Twitter to buy those tweets. You can pay Twitter to buy all the tweets that people are doing. So you can either use code or buy from Twitter. For CNN, probably the easiest way, you need to scrape the data through some modules, or same for Fox News. Google News, something similar. Or you can do manually or by code. So you can have someone to just go to the website every day and just copy and paste the document and put it in like a CSV document, or they can just copy and paste the Word document for you. So it's either manual or through codes. So I assume for CNN, Fox News, and Google News, probably you can do it manually, but for tweets is almost impossible. It should be like some automatic way or just purchasing. So you make your corpus document, and you need to use some modules to make it a numerical equivalent. Then apply machine learning. Sorry, my handwriting. Then check the accuracy of your model. Or on top of accuracy, you can do ROC or any performance measures. Previously, in the previous 9 experiences, we didn't use machine learning for finding the sentiment, if it's positive or negative. We looked up through some dictionaries that define if they're positive or negative, and we had like 70-something percentage as an accurate performance, which was accuracy. So this class, instead of using lexicon-based sentiment analysis, we actually trained some algorithm to predict our outcome. It could be something like predicting the stock movement. Is it going up or down? Or into the example, we predict the sentiment. Is it positive sentiment or a negative sentiment? Any questions so far? So in the next year analytics programming, I'm also teaching how to scrape the data. So this part is mostly out of content for this class. I don't think we have enough time, but most likely need some Python programming. So in fall, we cover some Python programming, which gives you knowledge how to scrape the data. But this course, we use some modules to just making the program much easier, and because otherwise you should like type everything. So with 9 modules, it's more like a drag and drop and just do almost all the analysis. But you also can Google it and see how we can use Python attached to 9 and how Python and 9 can work together. Maybe you can do some parts through Python, some parts through 9, and do your text mining analysis. Any questions? Okay, so let me stop sharing. Okay, I'm not sure how to start. So as you see, you can do sentiment analysis over voice of customers, voice of market, voice of employee. You can see what does your customer, market, and employee is talking about without doing a survey. First of all, a survey is expensive, and sometimes it gets outdated. Or more interestingly, in the last election, they spent a lot of time and did some scientific surveys about the people's idea about the election. But almost in all the surveys, they said the last US presidential election winner should be Hillary Clinton, but turned out to be Trump. It seems that when people when you approach them, ask them to do a survey, maybe they don't reveal what is actually in their mindset. But when they tweet, they are free to express their opinions. So they feel more comfortable, and probably if you do sentiment analysis, maybe you can get their idea much better. Or same for the market. Maybe I've noticed that I used to do some market analysis when I ask people, sometimes they are very angry about certain products, but at the end they just buy those. So maybe their answers and their reactions are different. Should I talk about that? So basically in sentiment analysis, which especially the one that we do today. So we have a corpus of data or a document that it's already trained and the sentiment is already classified. I mean, somebody looked at the documents previously and said, is it a positive sentiment or negative sentiment? Same as the previous one. So what we do, this time we take those documents and using the text that we have, we make some vectors, or basically this time when we do a stemming and look at the root of the words, we use them as a vector or variable, trying to predict the sentiment, which is positive or negative. So anyway, the dependent variable doesn't need to always be a positive or negative sentiment. This could be either stock market going up and down, or even it could be multi-class classification, or it could be a simple linear regression. So what I mean regression, let's say for a stock value, your dependent variable could be actual stock value, not just up or down, anything. So the module that you use for prediction should be different. So instead of classification module, you should use regression module. Let's do an hands-on experiences. Please go over your model and Okay. See if you're friend. So in your Moodle, please download sentiment classification file. So unload it. I give you a couple of minutes to do that.
So it's week 7 or week 8?
7. Do you see week 8 over there? I mean, it might be a bug in the system, but I don't think you see the week 8. Actually, we're in week 8.
No, it's my mistake. I downloaded week 7.
Oh, that's Actually, we're in week 8, but the materials is still from week 7, so it's the reason I'm still doing that. So for this week, we exactly try do similar process with a significant difference. Actually, this time we want to predict sentiment based on classification using classification algorithm, and not lexicon-based sentiment analysis. So if you have, let me ask you a tricky question. Let's say I just have 40 observations. Like here, let me stop share. Okay, let's say I just have 40 sentences or 40 IMDb review versus 4,000 IMDb review. And I want to predict the sentiment. So what's your suggestion? In which one should do you think it's better to use lexicon-based classification or analysis? In which one classification is a better option? Or people over Zoom, you can also bring your idea. You might mean the lexicon base. Does it matter how many documents or sentences I have? At the end, I just count how many positive and negative words I have in each sentence, right? So for example, I can, let's say if I have here, I have 3 positive words and 2 negatives. So the sentiment would be positive, right? In this one, if I have 4 negative, it will be negative. Does it even related to how many observations I have?
I think in the formula we divide it by total number of.
Yeah, actually, you know, we have two approaches. First, we just look at the positive and negative, and we set threshold as 0, and then the performance was not great. So we try to find a way to play with the threshold. So in that aspect, maybe you can consider, it depends on what threshold you use, but usually the threshold is 0, unless you are not very happy with the performance. So you try to play with the threshold.
So in our last class project with 0, the accuracy was 65%.
Yes.
But with me, it was better.
Yeah, maybe, yeah, but maybe we divided by, I mean, the second threshold might, yeah, but generally the threshold is 0 unless you are not very happy with your performance. But in classification, if you have more observation, you have better prediction. If you have too few observation, your prediction is not great. So when you have a large corpus, usually classification works better because more observation helps you to have a better prediction. But if you have very small corpus, just even if you have 2 sentences, you still can use lexicon-based prediction. But with just 2 sentences, training a model is not a good idea. Even you have 4,000 observations, you still can use lexicon-based prediction. May not be as good as classification, but still you can use it. So here, just lexicon, here, both. You can either use lexicon-based prediction or classification. So when you have a large corpus of sentences, you can use both of them, see which one brings a better performance. Previously, in previous class, they used lexicon-based, lexicon, not lexicon. So lexicon. So was about 70 something, right? 70 something percentage. Now we use classification to see if we can outperform the lexicon-based prediction or not. Any questions? Okay, so let's see what happens. Maybe at the end, we would see it doesn't work. Simple lexicon-based prediction might be better. Who knows? So people over Zoom, could you hear me?
Yes.
Okay, that's great. If you have questions, same as Punavit, you can use your microphone or you can text me over chat room. By the way, if some of my explanations or lecture is confusing, just let me know. I want to be explained to clarify everything. So no worries if some parts are not clear for you. Or if you want, you can approach me through office hours. So please use office hours if you're not comfortable to ask in the class. But I think every question should be a good question. So no worries if you think your question doesn't worth to ask. Probably your question is your friend's questions too. So even some of them are using this class in the asynchronous format. So you are helping them a lot if you ask your question over Zoom or in the class. So let's go each of them step by step. So in file reader, as you see, I'm reading from KNIME website, but most likely to be CSV file or other formats. You just browse from your PC and find the location. But here I'm reading from the website. I said it's a comma delimited. There is a header, so read column header here. As you see, is in a very comfortable format. Each reviews is in the text column. We have the URL for the movies, index ID, and also is somebody already read each review and classifies it as a positive or negative. So is it a supervised learning or unsupervised learning problem? Yeah, it's a supervised, because what does supervised means? Somebody already read the data and classify and put a label. The label could be here as a positive or negative class. It could be a stock market goes up and down, or it could be a numerical label. It could be just a stock value. At the end, there's a label. So we call it supervised learning. So we press OK. Same as lexicon-based sentiment analysis, we need to clean our data. Some of the words or characters are repeated too much. Some of them, like is, am, are, doesn't bring that much of meaning. Some are just numerical values, 1, 2, 3, doesn't seem to be that much of meaning. So look at the document creation meta node. I open it. In the first one, nothing, just converting our data to the format that is KNIME friendly. So CSV is a human friendly format. We convert to format which is friendly for KNIME for analysis. So the first one, I think for you guys is an empty string. That's fine. I'm just change it to column. So I'm just saying that there's a title coming from URL column, the full text coming from text, source, some of the extra, so categories from sentiment. The most important part is just identifying the text and category. Authors, title, source, these are some extra information. Okay, so, So when you run it, let me just show the output. You know, we make a new column. For you, you might be empty if you, in the settings, if here you choose empty string, and let me run it. Oops. Empty. Again, it's not empty, it's just all of the data is here. So basically, this column is just consolidation of text, URL, and sentiment. We just consolidate or merge in one column, which is KNIME friendly. So for you, it might be nonsense, but this one column has all information that is required for KNIME to do sentiment analysis. Column filter. For this process, we just need document column because it's a KNIME friendly and has all the information that KNIME wants for doing sentiment prediction. Execute. The next meta node is preprocessing. So you might, I don't do it now, but you might remember in the previous class, I said when you have too many modules, it might be hard to read. You select the one that are related to each other and merge it as a meta node. So if you want to expand it, you go meta node, expand. If you want to create meta node, you select some nodes and then select create meta node and just merge them into one meta node. Anyway, so let me go inside. First of all, we want to get rid of punctuations by applying over document, and as you see, we append a new column of preprocessed document. Number filter, we want to get rid of numbers and character. So here we just said any word that has 3 or less than 3 characters, just delete that. It could be a nonsense for us. It will be very short. And so here, a stop word filter. We just get rid of stop words. Case converter. So any word would be converted to lowercase. So for running everything up to here, I just right-click this one and execute. So it just do one by one up to the case converter. A small stemmer, we get to word stems. Oops. In back of the words, basically, after doing a stemming, we want to create bag of words for each sentence. Basically, let me just show you if it shows here. This is bag of all the words that we have. So they put in the one term column, and let me go back here. I don't want to leave them as empty, so here explanation might be easier for you. So here, when I do a string to document, don't leave it as empty, as a column URL. So there is no mathematics behind of that. Let me just go here, execute. I want to show you what happens if we do bag of the words. So we basically just find how many words we have in each sentence, how many sum of the words we have for each sentence. Okay, these are everything here. It's just for one review. As you see, their document title is same. All of them has come from imdb.com/title/tt0995752. So all of them are from one movie, but these are the words that are happened in that review. So if a review has 20 words, it creates 20 rows for them. So again, here we clean our text, getting rid of stop words, very low characters, numbers, and punctuations. With a stemmer, we just end up having a stem of each word, and then we create bag of the words. So we just end up basically finding all the words that are happen in each documents. Then here again, let me just show it to you. The words are in the term column, but it's more look at a list. We need to just convert the format into a string. So some words might be repeated in whole of the sentence. Some of the words are too common. Some of them are not too common. Let's say if something is not very common, let's talk about Punavit name. It's not here, but Punavit might be in the two sentence, but it's not that much of. It's just a one person name. It may not contribute that much. We might get rid of those names that are not repeated. Also, some of the words might be very common. They are not that. They're not contribute to. For example, in Clark University, word of Clark might happen in almost all the sentences. So it doesn't contribute that much in the sentiment. So we also want to get rid of those. How you can do, basically, you find the frequency of the words, and you might get rid of the words that are too common or are not repeated that much. So with TF module, we basically find the term frequency, execute. With group by, we group by the terms to find how many are repeated. And look at here, I put a maximum of 10,000. So what does it mean? When you group by, if it's something happened more than 10,000 times, it's a too common word. Like if you look at all of the documents in the Clark University, probably Clark and University doesn't contribute in the sentiment. Execute. Row filter. Here also we are saying that if it's a word repeated less than 20 times, probably there are some special words doesn't contribute that much in meaning. So let's get rid of them. So with the row filter, we look at the frequency of the words here. If they didn't happen that much, less than 20 times, we just want to get rid of them. So execute. So the one that didn't repeat it too much or just dropped from documents. Reference row filter. So in the lower part of this figure, we group by each term. If they are more than 10,000 times, we think it's too common, so they are not that much contributing in the sentiments. Is it positive or negative? Or if they repeated less than 20 times, we got rid of them. For us, more than 10,000, less than 20 are outliers. So now we want to just work with the frequencies, work with the terms that are not too common or not too much repeated, or just didn't have repeated that much. What we do a reference row filter. Basically, we keep the terms that are outcome of lower bound. So from upper bound, we want to work with the terms that are filtered from below section by row filter. We're just saying that check term as a string from the upper bound, connect to the lower one with the term as a string. Because in the lower one, we just kept the terms that didn't repeat it too much or are not, the frequency is not too low. So now what is remained? So let me just ascending. Then look at here. It just rounded up, doesn't show very well here, but if it didn't round up, you probably could see the differences here. So the relative frequency would be different. So anyway, what happened here, we cleaned our documents, get rid of subwords, numbers. In the last section, we got rid of the terms that are too common or too few. Any questions so far? Yes?
Sorry, I don't have the same interface.
With this one? You don't see these values?
No, from the back of Word. I don't have the same.
Let me see your laptop.
Yes.
Yeah. 0.018. The one that was
he changed the lattice and the frequency. And
instead of cause name, you have something. But the document and frequency document just keep open and you can mark. Now you have documents, your document column and precursor document are similar to me. I think in this assembly, now I have these two. Oh, no. I found an issue, so. Yeah, I have to do that. Okay, you just say. Yeah, we need to do term. Terms doesn't matter. So look at the one number. There is no difference. Just what you, it could be even empty. These are just for just showing them.
So your friend's question was why in documents here, I have link, but she didn't have the link. So the only reason here in the document creation, you wanted to convert your data in the non-friendly format. Instead of URL, you can select text. You can select, let me just put sentiment. Oh, sentiment, okay. Now I'm executing here. You can hear now I have pause. So it's not important, just for you can assume just a label. You could even have empty thing, but I want to put a URL link to show you that basically unique rows now repeated several times based when you do bag of the words. Because if they have 10 words, when you apply bag of the words module, 10 rows would be created, and each row has just show one word as a term. So let me go back here. In this section, let me just change it back to URL. But your outcome would be exactly the same, no big differences.
Hi, Hamid.
Yes?
Can you explain me again about the lower bound? You said that at 20, why?
Okay, so in row filter, I just look at the words. If a word doesn't repeat it more than 20 times in all the sentences, I want to get rid of it. Let's say I want to look at the students' tweet about Clark University. You have some friends, maybe in 20 of the tweets, there is Punavit. So if a word doesn't repeat it, if a frequency of a word is that much low, we can assume it's not very significant in making positive or negative sentiments.
Oh, okay.
Also, you can look at the tweets about Clark University. The Clark word might repeat it 10,000 times, more than even 10,000 times. So here, when I did group by, I just said get rid of any word that repeated more than 10,000 times. It seems it's a common word. It's not contributing in the making a sentence positive or negative. But weather or rain or snow, let's say, or sunny. So word of sunny is not it's one of the words doesn't have a low frequency or high frequency, but probably it brings a positive sentiment in the northeast region. Might people be happy if we have sunny weather? Again, these are not biblical conditions. So you can change 10,000 to 5,000 or 20 to 10 or to 50. So these are just based on your experiences and some subjective ideas. So you don't have to stick with 20. You can just change it to 10, 50, and just check your accuracy. So at the end, we look at the accuracy. If it's too bad, maybe the threshold that we use is not great. Maybe you can remove the threshold. You can keep all of the words. So these threshold, either 10,000 or 20, it's just subjective matters. And if our outcome is not great, maybe we can come back and change it.
Okay, thank you.
So we created bag of the words. We can now use those words as a variable. So each word can work as a variable to predict a sentiment. What was sentiment? Either positive or negative. So here, we just said, look at processed documents. The one that we get rid of stop words, end characters, whatever. So we want to create a bag of words. So right click, execute. Look at the variable words. Now each word is like a variable. Let me go to the end. Oops. Let's check another one of the, like, look at people. It's me. I just sort them based on the word of people. For sorting, you just right click on each word or column, then you can select ascending or descending. It might take too much time. Yeah, there's a huge data set. So look at people, it's not less than 20. Do you see so many one? It just means how many is repeated. And it should be more than 10,000. So now each word works as a variable. So with that module, document vector, we convert each word as a column to use it for prediction. Category to class. So it's nothing, we just said we want to extract class of each sentence from 9 friendly column. So from document, you can extract the class of each sentence. Is it positive or negative? You might ask me why we keep it somewhere, then drop it. It's not the only way that you can do 9 workflow. Maybe there's a more efficient way. So let me just right click and look at the outcome. Now I have some independent variables. My independent variables are words, right? And my dependent variable is document class. So is it positive or negative? You can use simple regression too. Look at the interesting thing. First, you have a non-numerical values, which are sentence. We created a bag of words and converted to columns. So now you can use even a simple regression to predict your dependent variable. Any questions so far? You know, let me just summarize the overall process. First of all, we have text and we want to predict sentiment. The column that you see positive, negative. So you cannot use a sentence into a machine learning algorithm. They just work with the numerical value. So what we did, basically we convert sentences to a numerical equivalent. How? We find a sum of the words, and each word could work as a variable. So existence of a word in a sentence means 1. If it's 0, means that word doesn't happen in a certain sentence. For example, in sentence or row 2000, you don't have tout, you don't have necklin, hemblin, whatever, rara, even some of them are nonsense. Sean, Kumar, it seems all of them are nonsense here. Even more interestingly, when you use lexicon-based sentiment analysis, the words should have a meaning, right? But here you can use a non-meaningless word as a variable to predict an outcome. So anyway, here there's an extra module. We just said, look at document class. If you see a negative, make it red. If you see POS or positive, change it to green. There is no mathematics behind of that, just some visualization. So when I look at table, so the positive are shown with green color, negatives are shown with the red color. Then the remaining are very straightforward, similar to a simple machine learning based project. We divide our data into train and test. Also, you can do 5-fold cross validation or anything, 10-fold cross validation. So here I just use a simple one for your learning, but if you want to check if you have overfitting or not, you can have 5-fold cross-validation. So the accuracy on each fold should be similar to tested. Is another one of the approaches to show. I'm asking you a question. Why we use 5-fold cross-validation? What is the application of 5-fold cross-validation? Why I just don't use simple train and test?
Probably to make it more representative.
Yeah, you are actually responding in a good way, but there's a technical term for it too.
Because we have divided it into 10 parts, then we have to, from each fold, we have to make sure that the standardization is not too much.
Yeah, very good explanation, but let me just explain a little technical way. Stop share. Okay, let's say this is my data set. This is my train set. I just showed it like a circle. I want to use it to train a good model to do a good prediction in future. So whenever I see a random new data, I can predict very well. What does it mean? I should have a generalized model. What does it mean? I want to be sure whenever I just throw a random set, it can predict very well. And basically, I want to avoid overfitting. What does overfitting means? Means you train your model very well now. It fits very well on your current data. It's overfitted, so you cannot generalize your model. Later, when you introduce a new data set, it doesn't fit well. So I have two approaches. One is let's say 70-30% train and 30% test. It's not actually too bad, but maybe it just happened randomly and you have a good model. Here, for example, in the train set, let me just show it. If accuracy or ROC, let's say talking about ROC. If ROC on my train, let's say 85%, and ROC of my test is 84.6. Pretty high and almost close to each other. So it gives you some confidence that although you use your train set to train an algorithm, when you have a test set, you can generalize your model from the train set to the test set. So it just means you could generalize your trained model from train set to a random test set. So if you can generalize in such a way, you have confidence to use it for future prediction. So let's say you have a new data. You can have more confidence that you can apply it here too. Apply with a good prediction performance. Let me just show you another shape. Even different color. So if you can generalize it over random test, in future when you get a new data, you can generalize in the new data. So, but for extra confidence, we don't want to just try it one time and test it one time. We want to do it 5 times or 10 times. When we can do 5 train tests, it brings you a good confidence that it could be well generalized in the future prediction. Any questions so far up to just one train, one test? So you see the application why we use tested and why the performance on train and test should be similar. If it's similar or close, it brings a confidence even in future you can have a similar good prediction. I'll just wait 1 or 2 minutes for people here or over Zoom to ask their questions if they have. I just want to be very clear for you. So if it doesn't anytime, if the material is not clear for you, no worries, just ask your question in class or later or over group me. So the big point I want to be very crystal clear for you. And even you see you're using modules, in future that you learn Python or if you already know Python or the programming languages, you just type it with your, you just type the commands. You don't use modules, but the logic is exactly the same. So this is just one train and test. So let's see what happens if we have 5-fold cross-validation or 10 folds. This is my data. Fold 1, 2, 3, 4, 5. So each of them should be 20%. Sorry, I'm not good in handwriting. Now, what I'm doing, fold 2, 3, 4, 5 for train, fold 1 for test. Then one, 3, 4, 5. Fold 2 for test. So this part is train. This part for test. Up to fold 1 to 4 for train and fold 5 for test. So we made 5 train and 5 test sets. Then we look at performance on each fold. If, let's say, if all of the train and test performance let's say I'm looking at accuracy, 85, maybe 84, 86, 84.5, maybe 85.2, 85.1. There is some difference, but not a very huge differences. And all of them I 5 times randomly train and test my data. So I have a good confidence, you know. I have very well generalizable model for future. So if I do 5-fold cross-validation or 10-fold cross-validation, now if I introduce new data, I have more confidence for a generalizable model, or more confidence for applying my model. No sign of overfitting. I can give you an example of overfitting. Let's say in one of my trained tests, my accuracy is 90% for train. So let me just erase now. But for test, my performance is 75. It overfit over train set, but you couldn't use it for a test set. So when you use, your performance is drastically different. So here I have overfitting. Overfitted on train set. On the train set. Yes?
When we use K-fold cross-validation, is that we use the average of the error fault of the train and compare it with the test?
Yeah, you can compare the averages and variances. You can consider both.
So,
For example, let's say, okay, let me just erase this. Okay, let me just erase this one. Okay, let's now it with my performance. 80, 84.5, 85.5, 85, 80, 97. And let's say two other are 85, 85.1, maybe 84.9, 84.8. Look at what happened. So in train set, there's a huge, the average is still around 85, but it doesn't seem to have a generalizable model. In some cases, there's a huge gap. But if you just take the overall average, maybe the overall average of trains around 85, and also for tests is around 85 too. Not a good model. So we don't just look at the average, we also look at the variance. The point of doing 5-fold cross-validation is bringing extra confidence for future use. So if you do the simple average, you just ignore your 5 times training. So you already spend a lot of time to train 5 times. You want to see, it should bring more confidence for you. You shouldn't ignore the information that you create. If I just do the mean, I ignore such a huge differences or variance in my train or test prediction. Other questions? Again, just be sure that it's clarified for you. No worries about your grades. The most important thing for me is should be crystal clear for you what you are doing. Because even if you learn Python or you're good in Python, you may forget the commands. You can Google and find those commands, but you need to understand why you are doing 5-fold cross-validation, how you interpret your analysis. Even, let me just close this one. Even 9 modules, you may forget it, it happens, but if you want, you can just easily Google, okay, what was the module for train? What was the module for ROC? What was the module for converting the cases? Here, I just do simple train and test, but you might remember in one of the workflows, I explained how to make a 5-fold cross-validation. But here, just for saving time, I'm just doing one train, one test. So with partition, I'm just saying 70% train, 30% test. As you see, I put a random seed here because otherwise, each time I might have a little different results. When you set a certain random seed, every time you get same results. It's not bad to have, it's not bad if it's not bad for sure if you have a little different results when you have different random seeds. But anyway, so I'm using train set, sorry, decision tree. You just need to show what is the class column. Also here, I think that should be enough, yeah. Also, there's some settings of decision tree. I don't go that much in details. You can use the defaults. If you want to know more about decision tree, please Google it. There's good YouTube videos that explain the settings of decision trees and what does it mean. Also, I'm using decision tree predictor to use the model to predict the outcome on test set. Let's just use the defaults. Anyway, I right click here, execute. Yeah, today we have, I think we already passed the class time, but please let's finish it. Yeah, class should be finished like 10 minutes ago, but I think it's good we spend a little more time to finish that thing. Also, I'm going to upload some extra videos for Tableau. So just in case if you need some extra training, but there's a good tutorials online about different type of visualizations. Okay.
Professor, by that I didn't get so just a question. The classification, if we take the reviews from newspaper, like somebody wrote an article on stock market or something, then as the classification takes every word as a variable, and it becomes a column header. So I mean, for that case, there will be multiple column headers. Like it might be hundreds of column headers.
Hundreds of words, you mean? Okay, columns even, or variables. Yeah. Actually, number of variables in sentiment classification might be might have 2,000 variables. Yeah.
Okay, so that's fine.
It's the reason it takes a lot of time. Actually, it's a really large data set because although we drop the words that will happen less than 20 or more than 10,000, you still have too many words remained. So at the end, we look at the prediction accuracy over a Scorer module and also ROCKF. Hopefully, it's better than Lexicon. Still, you can improve your prediction. And another reason I didn't use 5-fold cross-validation, frankly speaking, because I want to finish during the class time, which I couldn't. Even for one train, one test, it takes a lot of time. If I have 5-fold, it takes 5 times more than this. But for your project, please use 5-fold cross validation because your project you can run it overnight. I'm not sure if you are doing sentiment analysis anyway, but if you do any prediction, please use 5-fold cross validation. So, but I think if I had 5-fold cross validation, maybe it takes like half an hour or whatever. So ROC. So we look at the ROC of the prediction here. Let me just run it. ROC is 0.93. If it's close to 1, it's better. Very good ROC, actually. The settings are pretty easy. Just you need to specify document class. Like here, document class, either positive or negative, that should be fine. Scorer, let's see what would be accuracy here. Right click, accuracy statistics, 92.8%, much better than lexicon analysis. You still can have some improvement. One of them, I use decision tree. Maybe you can use other algorithm like neural network, might be better. Even you can improve more than 93%. Or you might remember here I had some thresholds when I group by. Maybe instead of 10,000, you put 5,000. Or here, instead of deleting the words that happen less than 20, maybe you can put less than 5 or just 0. Or just you can delete this module. So you can play with the data preparation part, which is here, or play with the prediction part here, or even within each algorithm, you can Google to see what those measure means. Maybe instead of quality measure of Gini index, you should put gain ratio, number of record per node. Maybe you can increase it, so you can basically tune each algorithm. So not only just changing from decision tree to neural network, you can also go inside algorithms and tune each algorithm. Or if it's your project, you can have decision tree, you can add another, you don't have to delete it. You can add one here for neural network, one for SVM. So you can do in parallel, actually. And for each of the sections, you can do the prediction. So let's say what I mean. So hopefully there's a neural network. Maybe SVM. Hopefully SVM is here. So what I mean, for example, here you can do SVM. And do same thing, sum score ROC for SVM or neural network. You can just keep adding. I just use another machine learning algorithm. You can Google for other machine learning algorithms and just use them. Maybe logistic regression is another one because your dependent variable just has 2 categories. Any question from people here or over Zoom? Sorry, it was a very long session. I just wanted to explain, so hopefully it makes more sense for you. Sentiment analysis is a really good topic. I mean, it's a very interesting topic if you are working in the finance or marketing sections, especially, or other sections, but it saves a lot of money and could bring good insights about what about your product or the market. Okay, thank you very much and have a great evening.